Hey guys, how you doing? So last video we ended up doing a very long algebra problem. It was also a limit problem, but it was more algebra. So today I want to keep going with the problems that I said I was gonna do. I got myself that lightly thingy, like that circle that just emits light, and I think it is pretty cool. You can see everything pretty clear. So I hope you guys enjoyed this video with a better lighting. Okay. So once again, I have my paper here, and we're gonna do some problems. So let's do them. First problem, let's go with it. We're gonna take the limit as h approaches 0 in the expression 5 plus h minus the square root of 5 over h. So now we can, oh my god, we can't plug in 0, so we need to do something else. We need to rationalize. So let's do it. We know we multiply by the conjugate, so we would have 5 plus h minus square root of 5. And now the same thing, so we don't alter the initial expression. Cool. Now let's distribute. So let me put the parentheses just to keep it organized. Now let's do, we know the two square roots, they go to a square, so they cancel out, and we get 5 plus h. 5 plus h, now minus square root of 5 times square root of 5 plus h. Now minus, we get 2 times minus? Yeah, we do get, oh no, yeah, I got like, why are we, yeah. This is supposed to be a plus sign, of course. So either way, we would have gotten this expression. Yeah, be very careful, guys. This is supposed to be a plus sign, okay? Because we're taking the conjugate of the binomial. We're switching the sign. I hope you got that one right at home. So either way, we would have gotten a negative, this negative product between this one and this one. And we would get a positive version of that same thing with these two terms. So we would get plus square root of 5 times. And now minus the square root of 5 times this. We know the square roots cancel, and we get minus 5. Yeah, minus 5. Cool. So now let's keep simplifying. We're gonna have 5 plus h. 5 plus h. We know these two terms, they go out. Minus 5 over, and now we need to, oh yeah, I forgot here the denominator. Maybe should we cross? No, we can't. We should not cross because we can cancel out something pretty straight up. We get h times square root of 5 plus h plus square root of 5. Now you see, we're gonna get 0 in the denominator. The 5s, they go out, and we're gonna have that. We can cancel out the h and the h on top. So we know this would be equal to h divided by square root of 5 plus h plus square root of 5. Cool. So the h, they both cancel out, and we're gonna get 1 over square root of 5 plus h plus square root of 5. Now we know the limit is h approaching to 0, so we don't change anything in there. So we get the limit as h approaches 0 would be in that expression, which would be just simply as if we evaluated the limit in the expression 5 plus 0, same thing, plus square root of 5. And this is the same as, my dog wants to go out of the room. He was like, giving me some company here. Now, bye-bye, dog. So, okay. And we know 2 times a term plus the same term, that's 2 times that term. So we're going to have 2 times square root of 5. And this is our limit. We have, the limit, we're going to take the limit as x approaches 9 in the function square root of x minus 3 over x minus 9. So now, what would you do in this situation? Well, now you might think, of course, we can't plug in 9. We should rationalize the numerator. Actually, no, we don't have to. I want to show you something pretty cool, and is that when you're taking a difference of perfect squares, technically what you're doing is just simply lowering the exponent, which is 2 that they have, to something that is not 0, okay? So now you want to lower 2, a power of 2, to something that is not a power of 0, because then we would get 1, okay? And we don't want that. So in this case, we know this would be equal to a plus b times a minus b. Now in this case, this is actually difference of squares because we can lower a power of 2 to something smaller than 2, but without getting to 0. Okay, so check this out. We know we have here an exponent of 1. If we want to lower this without getting to 0, well, what we can do is, okay, we know 0.5 is not 0 yet, so we can lower it to 0.5, and we know that 0.5 is the same as 1/2. So we can say this is x to the 1/2. And we know this is the square root of x. And if you see, if we also lower, this is 3 squared. So if we also lower a 3 squared to a lower degree, well, we can get 3 then. We can just put it to first degree. And if you see, well, then we'll be able to cancel out. So my point is we can do the following. Square root of x minus 3 over. And now here we get a difference of squares with this. So we say square root of x minus 3 times square root of x plus 3. If you see, this still completes the condition of a difference of squares. Because if you multiply square root of x times the square root of x, the square roots go out, and once again you get x to the first power. So this works. So we know we can cancel out these two. Oh, we can cancel out these two, and we're gonna get, this is the same as if we had 1 over square root of x plus 3. And now we can plug in 9 in there. We know square root of 9 gives us 3, so we get 1 over 3 plus 3, same as 1 over 6. And this is our answer without rationalizing. Of course, you can rationalize, and you should get the same thing. So our last limit problem with rationalizing. So we're going to have the following. We're going to have the limit as x approaches 2 in the function x minus 2 divided by square root of x plus 2 minus 2. Now if we plug in 2, this would give us a square root of 4, that's 2 minus 2 gives us 0. So we need to rationalize the denominator. So what we're going to do is we're going to multiply by the conjugate on the top and in the bottom. So we're going to have conjugate of this would be square root of x plus 2 plus 2, once again remember to switch the sign, over square root of x plus 2 plus 2. And now we need to FOIL the bottom. So we know the two square roots, they cancel out. And let me write the bottom first. So we're going to get x plus 2. X plus 2 now, 2 times square root that expression. So plus 2 times square root of x plus 2. We should get the negative part. Square root of x plus 2. And now we get minus 4. Cool. And now let's see how it goes on the top. So should we FOIL, we're gonna have these two terms, they go out. We get 2, positive 2 and minus 4. That goes to minus 2, x minus 2. And we have x minus 2 on the top. So yeah, we know we can cancel out straight up from there. So we're gonna have x minus 2 times square root of x plus 2 plus 2. So we know the bottom would be equal to, well, we have the top, x minus 2 times square root of x plus 2 plus 2 over these two terms, they go out, they're negative, and we're gonna get on the bottom positive 2 and negative 4. We get x minus 2. These two expressions, they cancel out, and we're gonna get just simply square root of x plus 2 and plus 2. Cool. So we know the limit is x approaching 2. So we know our answer would be the limit as x approaches 2 in the function. In this function right here, so we're going to have a square root of 2 plus 2 plus 2. So we have, this is the same as the square root of 4. Square root of 4 plus 2, same thing as if we had 4. Cool. And 4 is our answer. So I hope you guys enjoyed the video and managed to solve of all the rationalizing limits problems.